Hey, what's up? Jacob here as always, and today we're going to be doing part 2 of the engine coolant system. So let's jump right into it.
Go back.
So this here is a 1994 Honda Civic with the D15 engine. It's a 1.5 liter inline 4 that sits in a front wheel drive configuration. The problem that this vehicle is having is intermittent overheating issue. The overheating happens when it is sitting still for long periods of time. It doesn't happen immediately, and it does not happen when driving on the road. So with the problem identified, before we diagnose this issue and figure out exactly what's going on, let's first take a look at the coolant system and reference everything that we looked at in the diagram to in an actual vehicle. So we have our engine here, and this is our heat adder, okay? And the coolant pump is on the front of the engine, but the coolant is removed from the engine and put into the engine in the back here. So our coolant comes in from the engine hot once the thermostat is open. It comes into our radiator, travels down to the bottom, and then from the bottom, if you look right here, this is our output hose from the radiator, and this comes around and comes in to the engine on the back side here. You got your engine, your coolant pump is on the front of the engine, pushing coolant through the engine. You've got your outlet from the engine connected to the radiator, and then the outlet from the radiator connected to the input of the engine. In this vehicle, the radiator fan is electric. If I'm not mistaken, all front-wheel drive engines that have their engine like this are going to have electric radiator fans. Otherwise, how are you supposed to get a conventional radiator fan on the front of the engine to cool the radiator? Because the fan would be over here. So, in this circumstance, the problem that we're having is intermittent. I've heard this cooling fan, just like in the start of this video, this cooling fan has been cycling on and off. Here comes our radiator fan again. Before I started shooting, the engine started to overheat and this fan was not kicking on. If your engine is overheating, the number one thing that you want to do is make sure that, first of all, your coolant pump is pumping. There's two things that doing this here is. First of all, be careful when you do this. But you can grab this top hose quickly and carefully because it's hot, and check to make sure that it is in fact hot. And that's going to tell us that coolant is being pumped through the engine and out. So that means that the pump is working and the thermostat is open. Next, what we want to do is check over here on the back line and make sure that it is hot also. And that confirms that coolant is being pumped through the radiator and back out, back into the engine. So if these coolant lines are not warm and your engine's overheating, either A, your coolant pump is not pumping coolant through the engine, or B, you do not have coolant in your engine and in your coolant system, or C, your thermostat is not opening. So it's going to be one of those three things. But if you grab this and it's warm, then the next thing to check is going to be your radiator fan. So what you want to do is make sure that your engine comes up to temperature, and on your temperature gauge you're sitting close to halfway. And when you're sitting close to halfway, your radiator fan, if it's electric, should be cycling on and off. Here and there, it should cycle on and off. If it does not, and your temperature gauge continues to climb and get warmer and warmer, then there's something wrong and there's something not engaging your radiator fan. Now, in a setup like this, there's going to be several reasons. And like I described before, you have your electric radiator fan, then you have the wires that connect it back up over here, where it gets its signal. Then you have the components that process the signal. Then you have the wire that connects down to the coolant sensor for the fan. And then you have the coolant sensor itself. So we need to figure out why exactly we do not have our coolant fan turning on. In this case, it is still turning on. Like I said, it's an intermittent issue, but sometimes it does not kick on. Let's show how you would diagnose this problem. So for this demonstration, we need a source of 12 volts. And so what we're going to do is we're going to connect up to the battery, and then we're going to carefully and safely set our cables down so that we can basically use the 12 volts from our battery wherever we need to. And in this case, that's going to be to test the radiator fan if it was not kicking on, although in my case it is. And if in your case it is not kicking on, this is how you would test it. So step one is to take our ground clamp, and we're just going to clamp it somewhere, and we're going to take our positive clamp and we're going to clamp it somewhere else. Like this, it's not going to touch any ground anywhere, and I can just clamp it there and it sits out of the way. Now we're going to hook up our 12 volts. For this test, the best way to do this is to turn off the engine. In this case, it's also best to pull out this overflow tube and set it up out of the way. We need our 10 mil, our trusty magnetic tray. We'll set that over there. It's a great spot to put that. And now we can kind of move this out of the way a little bit. The next step is to carefully, and without burning yourself, unplug this plug from the radiator fan. And now I have two prongs in here. One is going to be for negative, and one is going to be for positive. And I'm going to use the plug to figure out which is which. So we've got a black wire, it's completely black, and then one that is black and red. I'm going to guess that the black and red is positive, and this plugs in like this, and so the prong that is closest to the driver's side is going to be positive from the way that it looks. So I'm going to connect negative to the side closest to me and positive to the side closest to the driver's side. We'll use green for ground, because why not? Now we've got this connected to positive, and I'm just going to tap this here. So when we send 12 volts to the fan kicks on. So the problem is not the fan. Okay, so now that we know that our fan is working, the next step would typically be to check to make sure that the controller that controls the fan is working. And so the next thing that we're going to do is take the relay that's for the fan and check it and make sure that it's opening and closing correctly. So the way to do that is to go to your fuse and relay box, and you can look on here and find where your cooling fan relay is. In this case, you can see our cooling fan relay is right here. And so the best way to pull these things out is either with a pair of pliers, or if you can get your fingers on it, just kind of grab it and wiggle it, and boom, it comes right up. And here's our relay. Okay? And there's the little prongs inside. This converts a sensing signal into a power or an operating signal. And the way that it does that is it takes a very low current or low amperage signal in one side that activates this relay. And then when the relay is activated, like a light switch, when the electricity activates this, it closes, it basically, or turns on the light switch and allows electricity to flow through it and turn on whatever it's turning on. And in this case, it turns on our fan. So just for simplicity's sake, you have one side that is the control side and one side that is the load side. And the control side gets small electricity to turn it on and off, and then the other side uses big electricity to activate and power the fan, or again, whatever it is that it's powering. And so the way to test this, one of these is going to be 12 volts, the 12 volt coil, and that is the controller basically, and the other side is just going to be, the circuit's going to be open or broken or closed and connected. And so depending on if you're sending a signal to here or not, it's going to be open or closed, open or closed. And there should be an audible clicking. And then also if you take a multimeter and run and put it in here, you'll be able to see that it's open and then closed and open and closed. So what we're going to do is we're going to power it and see if we can get it to close. One thing to note, on some relays, there is a diagram that shows where the coil is and what is controlled by the coil. In our case, that is not true, but there's only, these are color coded, looks like. We have two silver ones on this side, and then we have two copper looking ones on this side up here. And so one of those, the copper side or the non-copper, is going to be the coil, and then the other side is going to be the load. So I'm just going to connect across one and see if it closes the relay. So here we go again, using our 12 volts. And I'm going to connect our ground in here to one of these carefully. because I don't want to short this out. I like my little alligator clips. I don't want to burn them. Now we're going to clamp into the hot, and I'm just going to stick this in here. So we can definitely hear that this is opening and closing. Open, closed, open, closed. So it sounds like this relay is operating correctly. But we don't want to jump to conclusions. We want to make sure that it's operating correctly, and it is actually closing the contacts on the other side. So what I'm going to do is I'm going to connect this to power, and then I'm going to use a multimeter to check this side to make sure that it's closing correctly. Here's my multimeter, and we're going to go to continuity, and I'm going to do my best to kind of hold these in here because I don't have more alligator clips. But I'm going to take our ground, and I'm going to connect it to one side, and I'm going to take our hot and connect it to the other side, and look at that. It closes, open, close, open. So this relay is certainly working correctly. Now we're going to disconnect our hot because we don't want this alligator clip just floating around with 12 volts. So I'm going to put our relay back in. We know that this is not the problem. So through process of elimination, we know A, the fan works. B, we know that our coolant is pumping. C, we know that there is coolant in the coolant loop. And D, we know that the relay is working correctly. The only two things that are left for us are the wiring and the sensor. So the wiring or the sensor. And the wiring can be either from the controller to the fan, or it can be from the sensor to the controller. But typically wiring is not the problem. Typically, sometimes it is, but most of the time wiring is not the issue. So we know the fan works, not thinking about wiring. We know the fan works. We know the relay works. We know that the coolant system is pumping correctly. So the only thing that's left is the coolant temperature sensor that activates the fan. That's the only thing that's left. And through process of elimination, I'm going to kick the engine back on, and we're going to see if we can't get that sensor to fail. To anybody who's curious, this engine has 210,000 miles on it. And it sounds and runs great still. So by revving the engine like that, we're making there be more explosions per second inside of the engine, and so that's more heat per second that's being added to the engine block and thus being transferred to the coolant. And so that's going to heat up our coolant a little bit faster for us. So right now, our coolant temperature sensor is right about here. It's close to the middle point, but it's right about here. So anytime now, our cooling fan should kick on. So I'm going to take a look back here at the coolant sensor. There are several coolant sensors on an engine. One operates the coolant temperature gauge for your dash. One operates the temperature to operate the fan. And then one of the sensors is for the engine computer. So if I'm not mistaken, there's 2 to 3 per engine. And so if you can see here, I've got the plug to the coolant temperature sensor. That's for the fan. I can see that the coolant temperature sensor is pretty old. It looks pretty old. It's possible that it's still factory. And so it could be sticking for some reason. And the way that it works is upon detecting high temperature, there's a little connector in there that touches when it gets warm. And then when it cools off, it lets go. It breaks the connection. And so when that connects, it allows electricity to go through it up to our relay to turn on the relay. And when the relay turns on, as you saw, it activates and lets electricity flow through to the fan. And then when it cools off, it breaks the connection, so the relay does not have power to turn on anymore. And then the fan stops getting power from the relay. So one way to test this here is I'm going to take a little paper clip or something, and I'm going to put it in here. I'm going to put it in to make the connection and take it out to break the connection. And I'm going to check to make sure that it is getting a signal from here all the way through and turning the fan on, just to confirm that everything after the plug or after the sensor is working. All right, I found a paper clip. Thank God, I have like one of these in my house, and here it is. Who uses paper clips anyways? I'm gonna take this paper clip and I'm gonna make contact between the two wires. If you see here, there's two wires, one green and one black. I'm gonna make contact between them and see if our cooling fan turns on. Okay, so I just tested it 3 times in a row, and what that's telling me is the connection all the way through to the fan, all of it is working well. Unless, of course, the relay has an intermittent issue, but I don't think so, because I turned it on and off. Intermittent issues are difficult. There's no way of telling what's wrong when everything is working correctly. If I had to guess, and I do have to guess, my guess is going to be the coolant temperature sensor. But the goal of this video is not to point out what's wrong. The goal of this video is to show you how you can diagnose an overheating problem in your car. So I hope you guys were able to learn a thing or two about how to diagnose coolant problems with your car. If you got value out of this content, definitely leave me a like or consider subscribing. That helps me out and helps me to grow my channel and tells me I'm doing my job right and I'm helping you guys. And that's the ultimate goal for me here. If there's anything that you guys want to see, leave a comment down below, especially if you have any questions too. I want to answer your questions. And as always, thanks for being here. I'll see you next time. Have a good one.